All right, here's an example how you would find average velocity if your acceleration is constant. So in this case, the vehicle starts accelerating from rest. So they tell you that initial velocity is 0, acceleration is 2.5 meters per second squared. It lasts 4 seconds. There are several things that we need to find. We need to find average velocity. In order to find the average velocity, we need to find final first. And then once we figure out our average velocity, we can find displacement. So here's all our data. Initial velocity is 0, acceleration 2.5 meters per second squared, time is 4 seconds. Everything is in correct units, so I can skip this part. So equations. In order to figure out my final velocity from acceleration formula, final velocity is going to be changed in v is initial minus final, so when I rearrange it, final velocity is initial plus acceleration, because this is right here is the change in velocity. So whatever my initial was plus the change. My initial just happens to be 0, so this is easy. So my v final from there is just acceleration times time. Acceleration times time gives me 10 meters per second. All right, now what's my average velocity? From the formula that I just explained to you in the previous video, average velocity is initial plus final over 2. So the average of the two, 0 plus 10 over 2, 5 meters per second. And then finally I can figure out my displacement, and that is right here. This can be 2, 1 and 2, or initial plus final, whatever. Or this could be 0, this could be just v. The subscripts, as long as you just get used to one set of subscripts, they can all make sense. Anyway, so in order to figure out my displacement, I take my average velocity, which is 0 plus 10 over 2 equals 5, so times time, which is 4, gives me 20 meters. So here's the thing. Sometimes all they will give you would be acceleration, time, initial velocity, and they will ask you for displacement. So you could solve it the long way, as in find the final velocity, find the average velocity, multiply it by time, and that will be your displacement. In the next video, I'm going to explain to you, or actually in the continuation of this, I'm going to show you how to eliminate this extra step of finding final velocity. So I'm going to show you how to get to a shortcut to a formula that will allow you to find displacement having just initial velocity, acceleration, and time. It's called TimeSquare formula, and at least I call it TimeSquare because time is squared in that formula. All right, so again, I'm showing it to you in this video, so in case you need to go back, stop, pause, go over it one more time, you can do it at your own pace. So this is a formula that you already know. V final plus V initial over 2 times delta t is the formula for displacement, again, at constant acceleration. If acceleration is constant, then this works for average velocity. I just rewrote it. We had V initial plus V final over 2. Now I have V final plus V initial over 2. Not that big a difference. And then again, I know that acceleration equals V initial minus V final minus V initial over time. So from there, V final is going to be V initial plus acceleration times time. Again, you know that formula. And so what I want you to see is V final in this formula can be replaced with V final in this formula. So I'm just going to substitute and put VI plus acceleration times time over here. And to make it easier, and what I'm going to do is just get 2. Instead of having fractions, I'm just going to have 1.5 in front. So it's 1.5. Instead of V final, I'm writing V initial plus acceleration times time. So there you go. To help yourself, that right here and that right here. So I take this place in here instead of V final plus V initial delta t. You hopefully notice that I have V initial and V initial right here, so I can add them together. It's going to be 2 V initials. And then I also need to distribute delta t. So that's what I'm going to do in the next step. So my half, 2 V initials added together times delta t plus acceleration times time and times time one more time, time squared. So there's your time squared here. And then final touch, I simplify it one more time, so half goes away for the first part, and sticks to half the acceleration. So TimeSquare right here. Again, this will allow you to find displacement going straight for the data that they gave you in the previous problem. When they gave us initial velocity was 0, time was 4 seconds, acceleration was 2.5, and we found 20 meters. How did we find it? We went and figured out final velocity, found average velocity, multiplied it by time. Here, I know initial was 0, so this becomes 0. Half of acceleration of 2.5 times 4 squared. So I could have just found that in one simple step. Displacement equals half acceleration times delta t squared. If my object does not start from rest, I also have to worry about this part. So there you go. You will be quizzed on deriving this formula, so I would practice it. By deriving this formula, what I mean is I will give you these two equations. Delta x equals that, and then v final equals that, and you will have to fiddle with them and get to this one. So practice, practice, practice.